Today in this video I am going to give you some examples on binary operations, and the question is, which of the following operations are binary operations? So here I want to give you a quick revision of this topic. So I have taken three sums where we have to check whether the given operations are binary or not. So first one is star on z plus, defined as a star b is equal to a minus b. So as you see, let 3 and 5 are two non-negative integers. So if we take the operation 3 star 5, according to the definition it will be 3 minus 5, that will be minus 2, and obviously minus 2 is a negative integer, so it does not belong to z plus, which is set of non-negative integers. So we see z plus is not closed under the operation star, so here star on z plus is not a binary operation. As you see, star is defined on, which is a set of non-negative integers, and as we know that the product of any two non-negative integers is always a non-negative integer. So we may say that for all AB belongs to Z positive, A star B always belongs to Z positive. So here star on Z positive is a binary operation. The third part is star on Z plus. Star is the operation defined on non-negative integers as A star B is equal to modulus A minus B. As you see, the value of the modulus of any integer is always a positive integer, so we may take any two integer non-negative integers. So their A star B, which is A minus B, will also belong to Z plus, because modulus A minus B may not be negative. So here star is a binary operation. Now the next question we have taken as check the commutativity and associativity of the following binary operations. So here we are going to give you some of the examples to check commutativity and associativity of a given operations defined on a given set. So here the first sum is star on z, where z is the set of integers and it is defined as for all AB belongs to Z, A star B is equal to A minus B. So as we know, the difference of any two integers is always an integer, whether it is negative integer or positive integer, but it must be an integer. So for all A comma B, A minus B must also belong to Z, because Z have both the integers negative, positive as well as 0. So now we have to check the commutativity of So let's check commutativity first. So as for example, for any two elements AB from Z, A star B is equal to A minus B. If we interchange the places of A and B, we may write it as B star A. Now according to the definition, it is equal to B minus A. Taking minus common out of it, we have A minus B in the bracket. So if we compare these two expressions, these are different because it is only A minus B and it is negative of A minus B. So negative of A minus B may not be equal to A minus B. It implies that A star B is not equal to B star A. Thus, A star on Z is not commutative. Binary operations. Binary operation. Now we have to check associativity. Let A, B, C, three arbitrary numbers or integers, that is A, B, C belong to Z, that is A, B, C are three arbitrary integers. So if we take A star bracket B star C, first we apply the operation in this bracket. So we get A star B minus C. So now we have to apply the same operation between these two elements. Now first element is A and the second element is the bracket B minus C, and our operation is defined as the difference of these two numbers. So we have to write A minus bracket B minus C. If we open this bracket up, we get A minus B plus C. Now let's take the first two elements in the bracket and keep the third one outside. Now we have to apply the operation within this bracket. So we have difference of A and B, that is A minus B, and star C is written as it is. Now we get two elements. One element is the bracket A minus B and the second element is C. Now we have to apply the operation between these two elements. So that will be the difference of these two elements. The first element A minus B bracket minus second element is C. So opening up the bracket, we get A minus B minus C. Observing these two, we come to the conclusion that these two expressions are different. This is A minus B plus C and this is A minus B minus C. So obviously these two expressions are different. So it implies that A star B star C is not equal to A star B star C. Thus we may say that star on Z is not an associative binary operation. So this is the way to check the commutativity and associativity of a given relation defined on a given set. Now let's take the second example, that is star defined on Q such that for all A comma B belongs to Q, A star B is equal to AB plus 1. So star is an operation on Q. Q is the set of rational numbers, and for every two rational number AB, A star B is defined as AB plus 1, that is the product of these two elements and 1 is added to that product. So we have to check the commutativity of this relation now. Let A, B belong to Q. That is A, B be two arbitrary rational numbers. So A star B is equal to AB plus 1 as given. So now we change the places of A and B. If we interchange A and B in this operation, B star A, and that will be, according to given relation, BA plus 1. As we know, the product of any two rational numbers is always commutative, so BA may also be written as AB. So AB plus 1, and we give the reason because BA is equal to AB for all AB belong to Q. So we observe on interchanging these two rational numbers, we get the same result. So A star B is equal to AB plus 1 and B star A is also equal to AB plus 1. So we may conclude that A star B is equal to B star A. And hence star on Q is a commutative binary operation, Now let's check the associativity. So for checking associativity, we need three arbitrary elements. So let ABC belong to Q. A star bracket B star C, that is equal to A star. We keep A star as it is, and first we have to apply the operation inside the bracket B star C. So according to definition, A star B is equal to AB plus 1. So B star C will be BC plus 1. Now again we have two elements. The first element is A and the second element is BC plus 1. So applying again, we write the product of these two elements plus 1. So A BC plus 1 plus 1. So simplifying, we get, if we opening up this bracket, we get ABC plus A plus 1. Now if we group the first two rational numbers, A star B within bracket and star C outside, first we have to apply now the operation between A and B, which is AB plus 1 and star C as it is. Now we get two elements. First element is AB plus 1 and the second element is C. Now we have to apply the same operation on these two elements. So the operation is the product of these two elements plus 1. So bracket AB plus 1 into C plus 1. If we opening up this bracket, the C will multiply both the terms. We get ABC plus C plus 1. So if we observe these two results, obviously these two results are quite different because this is ABC plus A plus 1 and this is ABC plus C plus 1. So these two terms are different in these two expressions. So we may say that A star B star C is not equal to A star B star C. So we came to the conclusion that star on Q is commutative but not associative. Our next sum is let cap is a binary operation in the set of 1, 2, 3, 4, 5, which is defined as A cap B is the minimum of A comma B, then write the operation table for operation cap. So here minimum of A comma B means out of any two ordered pair, out of these two elements, which is minimum, that should be the answer of this operation. That if A is greater than B, the answer is B, and if A is less than B, the answer must be A. So how to write the operation table? So as you see, there are 5 elements in the set on which this operation is defined. So we have to make 6 columns and 6 rows in a table to write the operation table. So we always take number of rows and columns 1 more than the number of elements in the set. So there are 5 elements, so we have to make 6 rows and 6 columns. So 3, 4, 5, 6. Now 6 rows. First, second, third, fourth, fifth, and sixth. Then we write in the top left corner the symbol of the operation. Here the operation is denoted by cap. So we write this operation, and then we write in front of this symbol the elements of the set 1, 2, 3, 4, 5, and we write in the column below this again the same numbers of the sets 1, 2, 3, 4, 5. Then we read it as 1 cap 1. So 1 cap 1 means which is minimum out of 1 and 1, because 1 and 1 are equal. So we may say 1 is minimum out of 1 and 1. So we write 1. If we read it 1 cap 2, it means which is minimum out of 1 and 2, obviously that is 1. And 1 cap 3, the minimum of 1 and 3, that is 1. 1 cap 4, that is 1. 1 cap 5, that is 1. If we take 2 cap 1, the minimum out of these two numbers is 1. 2 cap 2, obviously 2. 2 cap 3, out of 2 and 3, the 2 is a smaller one. 2 cap 4, the result is 2. 2 cap 5, result is 2. Now we take 3 cap 1, that is 1 is less than 3. 2 cap, 3 cap 2, the smaller one is 2. 3 cap 3, 3, 3 cap 4. In the same way, we have to fill it up. So this is the way to write the operation table for a given binary operation. Next one is the operation star is defined on A, where A is Cartesian product of the set n, that is the set of natural numbers n cross n, and for all A comma B comma C comma D belongs to A comma B star C comma D is equal to A plus C comma B plus D. That means because the set on which star is defined, it is a Cartesian product of two sets. So every element of this set must be an ordered pair. So if we take two ordered pair out of this set and this operation is applied between these two elements, the result is the first two elements of the ordered pairs must be added together and second elements are also added together. So we have to check the commutativity and associativity of this operation. So let's check first commutativity. So we need two arbitrary elements. Let A comma B, C comma D be two arbitrary elements in the set A. So A comma B star C comma D is equal to, according to definition, the sum of the first two elements A plus C and the sum of second elements of the ordered pairs B plus D. Now let's check the commutativity. Now interchange these two ordered pairs. We have C comma D star A comma B. According to definition, the first two elements should be added in ordered pairs. So we get first plus second, C plus A, and the second element is the sum of second elements, so D plus B. As you see, C plus A is the sum of two natural numbers, and the sum of two natural numbers is always commutative. So C plus A may also be written as A plus C. In the same way, D plus B may also be written as B plus D. So we get the same right hand side for both these expressions, whether we write A comma B star C comma D or we write C comma D star A comma B. So after interchanging the elements under this operation, the right hand side, or we may say the result, doesn't change. So we may say that A comma B star C comma D is equal to C comma D star A comma B. This is equal to this, and thus star on A is a commutative binary operation. Commutative binary operation. Now let's check the associativity of the operation. For that purpose, we need three arbitrary elements in A. So let A, B, comma C comma D and E comma F belong to A. So the element A comma B is star, and the next two elements are grouped together in a bracket first. C comma D is star E comma F. So first we apply the operation on this. So first ordered pair A comma B remains as it is, star as it is, and here applying the operation we have C plus E comma D plus F. Now we have two elements. First is this bracket and the second one is this bracket. Now we have to apply the operation on these two elements. So according to operation, the first two elements should be added. So we get A plus C plus E, and in the second element these two elements should be added, P plus D plus F. Now we have to group the first two elements together in a bracket. So A comma B is star C comma D, and the third element should be written outside, E comma F. So applying the operation within this bracket, we have A plus C comma B plus D and star E comma F as it is. Now we have two elements. First element is the ordered pair a plus c comma b plus d, and the second element is e comma f. Now we have to apply this operation between these two. So according to definition, we get an ordered pair having the sum of these two elements. So we have a plus c plus e, and the sum of second two elements b plus d plus f. So comparing these two elements, we come to the conclusion that we have the same right hand side while we are grouping the second and the third term, or we are grouping the first and the second term. So we may say that here star on A is an associative binary operation.